Namaskar, welcome to Exercise Explained. In this video, I would be doing question number 11 and question number 12 of exercise 5B, Upthrust in Fluids, Archimedes Principle and Floatation, ICSE 9th Physics. The previous questions have been done in the previous videos, the link for which will be there in the description below. If you like the video, do share it with your friends and consider subscribing to the channel. Starting with the 11th question, a solid weighs 32 gram force in air. So weight in air is given as 32 gram force. 28.8 gram force in water. So weight in water is given as 28.8 gram force. We need to find volume of the solid and we need to find relative density of the solid and we need to find the weight of the solid in liquid of density. So we need to find the weight of solid in a liquid of density 0.9 gram per centimeter cube. So weight in air is given as 32 GF. So when we convert 32 GF to newtons, we need to divide by 100. So 32 gram force. So 32 divided by 100. So we get this as 0.32 newtons. So weight in air is 0.32 newtons. Weight in water. So weight in water is again given in gram force. So that is 28.8 gram force. When we convert it to Newton, again we divide by 100. So 28.8 divided by 100. So that is 0.288 newtons. So we have got weight in water as 0.288 newtons. Now we would be finding the upthrust. So upthrust will be using the formula weight of the body in air minus weight of the body in water. So weight of the body in air happens to be 0.32 minus weight of the body in water happens to be 0.288. So we get this as 0.230 and it will be in newtons. So we got the upthrust as 0.032 newtons. Now we know the formula upthrust is equal to V rho g. So I'll be using that formula. Upthrust is equal to V into rho into g. We would be considering acceleration due to gravity as 10. So upthrust is volume will be equal to upthrust divided by rho into g. So upthrust is 0.032 divided by rho is 1000 because for water density is 1000 into acceleration due to gravity is 10. So we get this as 0.032 divided by 10,000. Now that we have got this, we'll multiply numerator and denominator by 1000 so that decimals are not there. So we get this as 32 divided by, we have 1, 2, 3, 4, 5, 6, 7 zeros in the denominator. So divided by 10 to the power of 7. So we can write it as 32 into 10 to the power of minus 7. And since this is volume, it's going to be in meter cube. So we have got this as 32 into 10 to the power of minus 7 meter cube, which can be written as 3.2 into 10 to the power of minus 6 meter cube. Now when we convert it to centimeter cube, since we need to find the volume and the textbook answer is given in centimeter cube, so we will be multiplying by 10 to the power of plus 6 So 3.2 into 10 to the power of minus 6 into 10 to the power of plus 6. So minus 6 plus 6 cancels. So we get this as 3.2 centimeter cube. We can definitely leave our answer in meter cube, but since textbook one answer was given in centimeter cube, I have got it in centimeter cube. So now that we have the volume, we can find the relative density. So relative density formula, I would be using weight in air divided by weight in air minus weight in water. So weight in air is 0.32 divided by 0.32 minus 0.288. So we get this as 0.32 divided by 0.032. We multiply numerator and denominator by 1000. So here we get this as 320 divided by 32, which happens to be 10. So relative density, we have got it as 10. Yeah, relative density, we have got it as 10. So now we have got relative density. Now we need to find weight of solid in a liquid of density 0.9 gram per centimeter cube. So here we would need to find, we know the weight in air, we would need to find upthrust in that particular liquid. So I would write upthrust in liquid. So that would be equal to again V into rho into G. So V happens to be, we had got V here as 3.2 centimeter cube, or 3.2 into 10 to the power of minus 6 meter cube. So I would write this as 3.2 into 10 to the power of minus 6 meter cube into density of the liquid is given as 0.9 gram per centimeter cube. When we convert it to kg per meter cube, we get this as 900 kgm to the power of minus 3. So into 900 into 10. So once we do the calculations, we get here as 3.2 into, here we have 10 to the power of minus 6 and here we have 3 zeros. So that means 10 to the power of 3. So 10 to the power of minus 6 plus 3 gives us 10 to the power of minus 3. So 3.2 into 9 into 10 to the power of minus 3. Now 3.2 into 9 gives us 28.8. So we get this as 28.8 into 10 to the power of minus 3 newtons, since it is upthrust. So we have got the upthrust in that particular liquid as 28.8 into 10 to the power of minus 3 newtons. Now we would be using another formula for upthrust, that is weight in air minus weight in liquid. So upthrust will be equal to weight in air minus weight in liquid. So from this particular formula we can find weight in liquid equal to weight in air minus upthrust. Now weight in air, we know it as 0.32 newtons. So we can write this as 0.32 minus of 28.8 into 10 to the power of minus 3. So now 28.8 into 10 to the power of minus 3 can be written as 0.32 minus of 0.0288. So when we subtract this, we get it as 0.2912 and we get it in newtons. So this is the weight in liquid. So weight in liquid, we just found it as 0.2912 newtons. The textbook answer is given in gram force. So in order to convert it to gram force, we'll be multiplying by 100. So we get this as 29.12 gram force. It's not required to get it in gram force. You can definitely leave it in newtons, as newton is the SI unit. So I hope this question is clear. Getting to the next question, which is a very easy question. A body weighs 20 gram force in air and 18 gram force in water. Calculate relative density of the material of the body. So here we know weight in air is given as 20 gram force. Now when we convert gram force to newton, we divide by 100. So we will write it as 20 divided by 100, and this is going to be in newtons. So that is 0.2 newtons. Weight in water is given as 18 gram force. So again I divide by 100 in order to convert it to newtons. So we get this as 0.18 newtons. Now we know the formula for relative density as Rd is equal to weight of the body in air divided by weight of the body in air minus weight of the body in water. So weight of the body in air is weight of the body in air is 0.2 divided by 0.2 minus 0.18. So we get this as 0.2 divided by 0.02. 0.2 minus 0.18 is 0.02. We multiply numerator and denominator by 100 to remove the decimal. So we get this as 20 divided 0.2 into 100 is 20 divided by 2. So that is equal to 10. Relative density will not have any unit, so we would just leave it as 10. So question number 13th onwards would be there in the next video, the link for which will be provided in the description. Do check that out and consider subscribing to the channel. Dhanyavad.